Okay, welcome everyone to the webinar this morning. Today we're going to go over the Autodesk Fusion Simulation environment. So we're going to talk a lot about the extension, the Fusion extension. Now, at Symmetry, we have been working through some different subjects with the extensions. So not that long ago, Brian Fagan basically did another part of the Fusion extensions, which was based around the machining extension. So there should be a link to that on our website, and today I'm going to focus on the simulation extension, and then we do have one more webinar coming up, which I'll give you more details around at the end of the presentation. So just a bit of an introduction to myself, guys. My name is Cheryl Snedden. I'm part of the manufacturing team at Symmetry based in Scotland in the UK, if you can't tell from the Scottish accent. I've been with the company now for about 10 years, as I say, part of the manufacturing team. Most of my projects I work on advanced manufacturing and simulation, but I do have experience in other areas of the business as well. So yeah. Nice to meet you all. So today, like I said, we're going to be going over the Autodesk Fusion Simulation Extension. So this is the agenda for the time that we are together. And we're going to look at gaining access to the extension, and then we're going to take a look at the advanced studies, the types of studies that you can do with the extension. We're going to look at maximising your efficiency, so how you can work with the cloud, and then some insights around the static analysis and generative design functions within the extension. Okay, so not that long ago, guys, just some information about the extensions themselves. So if you have been a long-term Fusion 360 user, a few weeks ago, or maybe even a month ago now, Autodesk announced a rebranding of the product. So Fusion 360 is now Fusion, and this is where Autodesk are basically moving forward with this platform vision that they have for the future. So if anyone's got any, or if anyone was able to visit Autodesk University last year, there was a big push on Fusion as a platform moving forward. We talk more about the industry cloud and the access to connectivity. So Autodesk are, building their way towards this platform with consolidation of the extensions. So now they're making it a good bit easier for customers to understand what extension they need to do a certain task within the software. So now we've got an extension based around design, which is product design. We've got one for signal integrity, which is based around your PCB and electronics. We've got our Fusion simulation, which is the one that we're working with today, which is now all of your simulation and generative design functions. The machining or manufacturing extension, I keep calling it machining because that's what I was used to before. Manufacturing extension was the one that Brian went over in his webinar not that long ago. And then that extension itself, the manufacturing extension, has actually grown so much now that it's got nesting and fabrication as well as additive build. And then we've got the manage extension, which is based, for anyone who doesn't really know much about the manage extension, it's based around some soft data management of your files, more than version control. It's revision control as well as change order management. So back to focus on the extensions in general. So why have Autodesk got this set of extensions? Autodesk don't class them as add-ins. They just, they class them as extended tool sets that allow you to scale your workflows and add in the tools that you need when you need them. So basically expanding your capability and giving you the functionality that you need over a flexible amount of time. So that amount of time could be yearly. Now that's 1 year or 3 years, or monthly, 1 month, or even by flex, which is pay as you go. Now there is a bit of a change in the extensions as well. It used to be cloud credits, but now Autodesk are working with the flex tokens, and that's pay as you go. But if you have any questions about how to purchase or anything like that, please get in contact with us and we can help you to understand a bit more about what one suits you perfectly. So let's take a look at the different studies that we can do within the Fusion extension. Now the simulation extension itself has now grown so vastly. Some of these features, some of these studies that you can run are not, are not available in even Autodesk's Inventor product. So this is a very, very, for me, it's one of the best extensions. It gives you a whole host of things that you can achieve, especially if you're working with design and manufacture. So for me, manufacturing is the source. It really is the place where you should be focusing, and also, we hear our customers telling us that there's always problems, there's bottlenecks, and there's always that kind of gap between design, engineering and manufacture. But with the tool set that you get with the simulation extension, designers can now branch into skill sets that they might not have necessarily had to have in the past. Now you can open up this gate to simulation extension where you can run simple studies and build your skill set within the software and allow you to, expand within your manufacturing capabilities. So non-linear static stress based around your structural loads for large deformations. There is a possibility to use materials that are non-linear. So again, that functionality is quite high end and it's part of the extension now, which is fantastic. We do have the event simulations for both dynamic and quasi-static events, which are based around single part or multiple parts, which give us again the ability to use non-linear materials. Injection molding, which has been part of the software for quite some time now, will allow you to basically create scenarios in which you can see injection locations using standards and guides for your results. You've got structural buckling, which is, again, if no one's ever used any sort of buckling before, it might be worth you having a look at some structural buckling. But that includes corresponding load multiples, which is quite an interesting part of the software. Then you've got modal frequencies. To be fair, it's been part of the software for a while. It's very good at what it does, and you can use it to run frequencies through your part and get some results. Then we've got thermal steady state and thermal stress, which is really important if you're working with heat and temperature. And then shape optimization, again, is something that's in the system. It's been around for a while, but teamed up with generative design, it really is a fantastic tool to allow you to lightweight your components. And generative design is a fantastic addition to add manufacturing capabilities into the creation of parts. So you can create your part with manufacturing criteria, which is again a fantastic addition to the extension. Now, for me, I just think that's a hell of a lot that you can do within one extension, and you don't need to be the master of all. You could be focusing on one or two of those areas. Now let's just take a look at the Fusion. So I'm just going to jump in and do a bit of static analysis and show you some of the results within the generative design studies. So I'm just going to stop sharing just for now, and I'm going to bring up and then start sharing again so that you can see my screen. Elaine, can you see my screen all right?
Yeah, perfect, right? You're in the software. Yeah.
Thank you very much. Okay, everyone, so I'm inside Fusion just now. I'm just going to walk you through the creation of a static analysis. Now, just to give you an idea, up at the top right-hand corner here is where you get access to the extensions. So at the moment, the active extensions that I have are the ones highlighted with the green icon at the bottom left corner. If I click on simulation, it will take you through some information that I just discussed with you and some documentation around the different types of studies. Now, if there's something that you want to do within this extension that you don't know how to do, then please get in contact with us and we can help you to start the journey with simulation. So I'm going to open up a new part here just to give you some history on this part. It's actually come from a company called Magnet that do solenoid solutions. And this small component that you can see in here is the component that we're going to analyse. Now, if you look at it here, it's got three main connections within the solenoid as it works. And there's some data as well that can be gathered from the data sheet. So you've got some information here based on the materials and things like that. And this is all off the customer website. So this example is the example we're going to use. So these are the three connections that we're going to use here. And we're going to add some loads and constraints through the simulation environment to analyse the material. So we're just going to dive into the simulation environment. Now this is where you pick the study. So like I mentioned, these are a whole host of different types of studies. If you select on another one, it will give you information about what that can do for you. So we're going to go with a static stress, and we're going to analyse it in the static stress analysis. For anyone who's ever done any FEA before, there is a kind of a step-by-step process that you take when you're building up an analysis within any FEA software, and Fusion does it just the same, just as well. You know, you can simplify the model. Then you would do things with materials, add your constraints, loads, contacts, displays, things like that. So then you would look at the results. After you've ran the results, you would look at the display in a bit more detail. So we don't need to simplify the model, but we do need to give it a material. So I'm going to click on materials. There is a material library which is applied inside of Fusion, and most of the materials that you'll be working with will be there, but there is the option to add your own if need be. So we're going to go with a mild steel for this study. So now that we've applied the material, the next thing I'm going to do is apply some constraints. So for the structural constraints that we are going to use in this instance, we're just going to apply some pinned constraints, one being on the inside of this cylindrical part here. Now if we just go back to the example just to show you, it is fixed in these positions, but at the top it's got a bearing load which is moving in the lock itself. So that's the type of solution, or that's the type of setup that we're working with inside of the static analysis. So we're going to place on the bearing load. We do have options in the bearing load to work with radial or axial or tangential directions. So we're going to apply and activate the radial and axial and click OK. And then we're going to do the same with the internal face here, just to pin the internal face at this end. So I'm going to go back and apply another pin on the internal face. And you can see that what the system will do is it will add glyphs. It will also add them to a caseload. So we've got our caseload and our material. We've got our loads and our constraints. Okay, so from there I'm going to apply a load to the face on the inside at the top here. This is the face that will be flexed up, pulled up whenever the lock moves, it basically pulls up on the surface at the top. So we're going to represent that with a bearing load on the face here. Okay, and when we work with analysis, we can work with different types of direction. So direction types are very important when we work with simulation, so that we can tell it that we're either going in a positive or a negative direction, and then what way in the view cube are we going? Is it X, Y, and Z? And then we obviously can analyse it from there. So from here, what we're going to do is we're going to change it to a vertex, sorry. And then we're going to apply a bearing load of minus 30 newtons in the X direction. So that corresponds with the view cube. So we've got our view cube up at the top here, and the X direction is the positive direction there, but we want to pull it in this direction. So we're going to go minus 30 newtons in the X direction. Okay, and one of the things that you'll find with Fusion is it's a simple process. It's not overly polluted by clicks and picks. It's very obvious where you need to be. If you've used other analysis software before, you will find it fairly easy to be able to run a simple static analysis within the software. So now that we've done that, the one thing that we need to still do and work with within the software is the mesh. Now there's various different settings for the mesh. Today we're going to go for an absolute 0, which means that we can say that our element sizes are within a range. Now there are other ways to work with the elements, and again, if you've got any questions around this afterwards, then we can help you to understand it a bit more. So I'm going to change the size of my mesh control to 2.5 millimeters. And then for this example, I'm just going to run the load case and solve it. Now, everything that we do when we work with simulation goes to the cloud. So we have the option to use the cloud, and what we want to do is obviously use the cloud as much as possible. It is a cloud-based software. It does take time, like any simulation, but it's not it's not a lot of time. So you can see that the information in the job status is telling us that we have a simulation running. It's actually solving just now. It gives us a percentage of that solve. If we look at things like generative design or drawing animation as well, these are the types of jobs that go through the job processor up to the cloud, and it comes back and the software will tell you when your simulation is complete. So we do have notifications that come up in the top. We do also have a bar down at the bottom here. So it will tell you the progress of the simulation. If you have multiple simulations, they will, jump on top of each other, and you'll be able to see the slider bar at the bottom on the left. And then you can expand up the job processor at any point from the bottom of the screen as well as the top here. Okay, so I'm just going to open up one that's complete just now, and we can wait on that one running through. So if we look at the results for the 2.5 millimeter mesh, we'll be able to see that that basically there are maximum and minimum stresses within the part. If we look at the load case, we can exacerbate it. So at the moment it's on 0 deformation. If we look at the bottom of it, we can see, and we can change it to actual 2 times, even 5 times, which is pretty crazy, but we can adjust how it looks on the screen. We do always kind of exaggerate the amount that we can see it by, so that we can really see where the force is going to be, so that we can tell whether it's going to be a problem. And that's the job finished, so it's only took a few minutes. But what we can do with the results is, if we come back to the deformation, we can look and display in different areas. So there's a lot of stress here. If we want to probe that stress, we can just take a probe from the inspection drop-down list, and it will tell us the amount of stress. Now, it's not just stress that we can analyse. We've got the opportunity to do factor of safety, stress, displacement, reaction force, strain and contact force as well. Now, that's a lot for this environment. Again, you do get a lot for your money with the simulation extension for sure. Now, if I just go back just to show you that the results were ran, when the results run, this result window comes up and gives you some information about the factory safety and things like that. It's quite a nice dialog box, but it can be turned off if you don't need to use it. And then from here, you would go through a process of looking at the stress, displacement, things like that. Okay, so reading the information, viewing the information, digesting the information into Fusion is very easy. The icons are really easy to understand, to work with, to digest. So if we go back from the results, what we can do here is we've got a mesh which is running. Let's just put the mesh on so you can see it, where we can then copy the study. So we're going to clone the study. We're going to end up with another study, and we're going to change the mesh size to take it down to 1.25, and we'll run the results on that one as well. Again, we're just sending the information up to the cloud, and I'll come back into this already solved. Is it completed already? Well, that's nice. Lovely. Where we can look at the results. Maybe it's not completed actually. Let's just double check. That's still running. I thought that was quick. It was just the old, I think it was the old notification. Okay, so we can look at the second one here where we're waiting on the results being run. I just want to let them run in the background just so you can see how quick they run as well. So it's just giving you an idea of pre-run and solutions as well. So from here, again, we do have that high stress, so we can go back in with a probe. And I think it was 8 point something the last time, so it's up at 9.5. And again, you just need to be careful with the mesh convergence whenever you're working with static analysis, where if you increase the size of the mesh too much or decrease the size of the mesh too much, you end up with singularities. Now that is an FEA thing that happens in any software. But yeah, what you would tend to do is maybe run 3 different sizes of mesh and then converge the results manually with maybe some hand calculations and just skill set as well as knowledge about your product, knowledge about your part. So we cancel that one out. Let's just go back and see if the results have been run on this one. They're still running, so we'll just go on to the third one. So the third one, basically, what I did with the third one was I went in and I created what we call a local mesh. So the local mesh, I think that's that one done. So we took a look at the results. So we can just clone that one again. So we're going to clone that study, and this time what we're going to do is we're going to leave the mesh at 1.25 millimeter, and we're going to add what we call a local mesh. So the local mesh is basically allows us to come back in with, so let's just activate that, and we've got our mesh settings. Yeah. That's fine. We're just going to double check this mesh is 1.25, which it is. Fantastic. We'll just turn the mesh on. Yep, generate the mesh. I'm getting confused by the two of them, having them open at the same time. Okay, so that's the mesh generated. Now, what we can do with the mesh is we can create what we call a local mesh in just this one face. So the mesh is there. What we can do is just look at these mesh settings again, 1.25, which is fine. We'll finish those results. Come back out and look at this one. It's home position. So from here what we can do is we can add a local mesh. So in this one here what we've done is if I edit that study, I can look at the local mesh settings and edit those. And you can see here what I've done is I've applied a local mesh to just this one area, and I've took it down to 0.5 millimeters, and then I've ran the mesh again. And again, there's no difference between the stress. It was 9.6 in case study in study number 2, and now it's 9.8, which is increasing, which makes me start to think that if I go any further down the line, it's just going to be stress singularities that I'm going to start getting in that area. So when you're working with the studies, it's still the same as most FEA. You do need to converge using your different style of mesh. You can use local mesh controls. You do have results which you can look at and compare. You do have the display settings which you can, look at your deformation. You can compare two different results side by side. So if we've got two case loads, we can look at case load number 1, for instance, with the stress. And if we click on the left-hand side, we can look at the stress and the others. So I'm going to show you another example of this that might be a bit better, and that's from the generative design environment. So whenever you work with generative design is basically a front-loaded process that allows you to add manufacturability constraints and criteria to your geometry before you run any sort of simulation on the part. And if anyone's done it before, you get these really organic shapes from generative design, but it means that you can produce parts that maybe the human mind would never think about doing. So instead of having those traditional kind of a design reviews based on concepts that have came from either your mind or a group of minds, then you front load the system with generative design, and basically with generative it creates multiple solutions based on your manufacturing criteria that could be material, machining capability, additive machining, subtractive. And again, that's part of the simulation solution. So when we purchase the simulation extension, we get access to generative design, and it works really well with simulation, static simulation. It works really well with lots of different styles of simulation. Now, I thought I would just show you an example of how that would look. So with the example, which this example is available for you to have a look at afterwards. This is an example took from the samples of the product documentation. Now there's 1, 2, 3, 4, 5 case studies or case load cases applied with generative design. Now with generative design, what you do is you would take let's look at the bodies. I'll just put all the bodies on so you can see them. You would go through a process of saying, right, okay, well, the green areas are the areas in which my component will be preserved, and the red areas are obstacles of the geometry. So therefore, whatever generative design does to grow through those areas, it can't touch the red areas. So again, it's very much like simulation. So you do have to add design constraints like loads. And one of the most important things about generative design and simulation is when you set up the load cases within generative design, it carries it on through into the simulation environment, and it allows you to take a design study and then study it within the simulation environment. So what you would do is after you've ran your generative design, it will go up into the cloud through the job status. You can see here that I've threw up some information and created some structural components before this webinar. So once I've done that, it will then come back with all the explored possibilities and manufacturing methods that I specifically inputted during the process. So within the generative model itself, you get a whole host of concepts instead of just having the one or two concepts that you maybe were able to focus on during your everyday tasks. So it takes away a lot of the thinking, but you still need to have skills to work with this process. So once you pick, you can pick one or two of these models, and then you get the opportunity to create a design from them. Now you can go for a solid model or go for some sort of like mesh as well. But when it comes out the back of the software, it will generate a part, it will go up to the cloud and it will generate the part, and the part will come down, it will open up. When it opens up, it will then prompt you and it will say you already have generative design capability cases within this file. Do you want to use them within simulation? And you would say, you would say yes to that, and it would then filter through all of that information. So if I'm just going to send it up. I'm just going to open up one of the designs that I've done before so that you can see. So this is a design that's came through from generative design. So it was basically generated from the model that I showed you previously. So it was the green areas that were preserved and the red areas which were obstacles, and it's created this solid part for me around that set of criteria. The loads and constraints and everything that were applied will now be able to come through from simulation. So when you take it into the simulation environment from generative design, it will say, we know that there's been studies in here before, do you want to bring in the loads and constraints? And you can say yes. And what it will do is it will bring in all the load cases that you applied to the part previous, which I think is quite a fantastic feature. To be fair, I think it makes sense to be able to do that, because when you're analysing, you really only want to apply that information, the constraints and the loads maybe one time. So from here, what you can do is you can then, look at the results of each of compare the information with the results. So I'm just going to open up an example that I've got previous, just so that I know this one. And then we can look at the two comparisons. So say on the left-hand side, you want to look at something like stress and you want to look at load case 1. On the right-hand side, we can look at load case, say, 3 or 4, and we can look at the stress in that one as well. And as we move it around, we can see the different areas. Now, load case 3 and load case 4 have the arrows pointing down the way, but they're both fixed in different areas. So load case number 1 is fixed at the top here, and load case number 4 is fixed in the centre. But again, being able to just compare those results side by side is a huge, huge advantage. Being able to use simulation for all of those different types of simulation within the extension is huge. We have softwares from other third parties that don't have as much of that information, or as many of those different styles of study within one extension. So you really are getting the full benefit of simulation in all areas within the extension. Okay, so I've literally been speaking the whole time. I think that's me done with presenting. I think you've really got the gist of how important it could be to run simulation. If there's any questions, guys, please put them in the chat. I'm going to go back to the presentation just to give you some information about the next webinar and finish up with some questions. So we've got about 5 minutes. We can maybe just be over slightly, if that's all right, Elaine, if there's any additional questions. But I really wanted to make sure you had the whole picture, guys, of what was capable. So I'm just going to stop sharing just now, and I'm going to bring up my slideshow again and start sharing from here and just give you some information about the next webinar. So We have been hosting, like I said in the beginning, we have been hosting webinars. Brian did one on the manufacturing extension, so if you want to see the recording of that, please do go to our website. This recording will be sent out to everyone afterwards, so hopefully you'll get some benefit from that. And then the next one's going to be run by Jonathan at Autodesk, based on fabrication, so that'll be an exciting one for anyone who's interested in nesting and fabrication. Really appreciate you being here, guys. It's been fantastic. Yeah, so join us on the next webinar, and if you've got any questions, get in touch.